at least your living room. Not to mention it doesn't play well with computers, so you kind of have to segregate your life. You can create flexible rope out of spherical magnets. That was an interesting discovery. And the forms kept getting more and more complex, and eventually I had a gallery show here at the Gray Area Foundation for the Arts, where I showed a bunch of magnetic sculptures. And if I learned anything from that whole experience, it was that you should not show delicate, shiny metal sculptures at toddler height, which is like about 2.5 feet, because their arms just reach and then the whole thing collapses and parents look shocked and I'm pissed, and the sculptures didn't last for very long. I would like to eventually get a hold of more options for diameters, because if you're limited to 4 different diameters that you work with, you can't create a more exciting form like this sea urchin photo that I stumbled upon, which kind of messed with my head at first, because I just assumed it was a render, and it turns out it's not, and that's it's both disgusting and awesome at the same time. It's like there's a zipper form running through it. I don't quite get it, but I'd love to own one. So I made a bunch of these sculptures, and they ended up in many ways influencing the work that I'm doing with code. So whereas I started with the single spherical magnet with that simple rule set, the corollary in the virtual world would be a particle, and the first rule that I give these particles is that there should be a gravitational attraction, or just call it attraction and repulsion. It's, I'm not necessarily using the gravitational equations as they were established many centuries ago, but I'm just making any particle on screen pull every other particle on screen. And after a while, you start to see these familiar forms that you would have noticed in the magnets. There's lots of tight packed hexagons. It's circle packing, it's sphere packing. There's this look that they have. Of course, I'm the guy sitting at the outdoor cafe drinking champagne, filming the bubbles coming up from the bottom of the glass, because it kind of looked like that thing I did the other day. Well, it makes sense that it would, because it's still dealing with circles and packing circles together as tightly as possible, but I found this probably more intriguing than I should have. And I hadn't even really had any of the champagne yet. So when you start to introduce the rule of attraction and repulsion together, working in tandem, you can think of it as each particle is given a random charge, either a positive charge or a negative charge, and you all know that opposites attract, likes repel. So that's the rule set that I'm going to be working from. So you throw a bunch of these particles into a space and you give them those rules and you let them do their thing, and they start to do things which you wouldn't expect. I wouldn't have expected that they would have started spinning. And they're not spinning all in the same direction, they're just spinning. They attract 6 of the smaller particles. That's too much for them, so they start to spin and particles will shoot off, they'll stabilize, spinning will start again. Didn't expect it, it was amusing. So, slightly larger simulation. I'm just gonna, I've been thinking of this as water molecules, even though I'm not really using the numbers from the periodic table of elements to define these forms. But the blue dot would be like the oxygen, and then you've got the 2 hydrogens. If I drop one more hydrogen into the center of this sim, oh, there we go. It falls apart. The chaos just begins to spread, and they start to clump together in ways that make sense. You start to see lots of hexagonal packing. Eventually they stabilize a bit. And it got me to thinking that maybe this is how water turns into ice. Maybe this is not actually all that far off from what chemists are observing when they lower the temperature of water to see the ice crystals form. Could be something like this, I don't know.